In this video, we're going to talk about how to calculate the mean. The mean is one of the measures of central tendency, and the measures of central tendency are important methods for describing data with numerical measures, and that's the unit that we're in, describing data with numerical measures. Just a quick look at the mean. Let's talk about some of the features of the mean. It's the arithmetic average of a distribution of scores. I would say it's the most frequently used measure of central tendency. Simple calculation. We calculate the mean by summing the scores on our variable and then dividing by the number of scores, by the number of observations. We'll do a couple of sample problems here in a second. If you're using the mean, the data must be measured at the interval or ratio level. You can't use the mean with nominal or ordinal level data. It has to be interval level or ratio level. One of the deficiencies of the mean as a measure is that it can be greatly influenced by extremely high or extremely low scores in the data. And here's an example of how an extreme value can skew the mean and may result in somewhat misleading description of the data set. We have a company with 5 divisions. 4 of the divisions have 6 injuries per year, but 1 division has 34 injuries in a year. The mean injuries by division is 11.6 injuries per year. That mean has been pulled up by the 1 division having the 34 injuries. And that mean of 11.6 may not really be representative of what's going on within the company in these 5 divisions. If you look at 11.6 and think of those being distributed equally across the 5 divisions, you think, well, we need to work on this as a company in all divisions. But when you look at specific data values, specific measures for a specific division, we see that we have 1 division where we may need to focus more of our attention. But that's just an example of how the mean can be influenced by extremes, something to take into consideration. Normally, when we have good data, we have sufficient data values, large enough data set, it's not going to be a major issue, but it is something to keep in mind. Here are the formulas for calculating the mean from more of a statistical lingo standpoint. We can talk about 2 different means. The mean of a population, which is mu equals the summation x divided by big N. Then we can talk about the mean of the sample. X bar or bar x is the symbol for the sample mean equals summation x divided by little n. Now the calculations are the same. Nothing's really different as far as coming up with calculating the mean of a population versus the mean of the sample. Now when we get into other statistics, other measures, such as variance, then we have to make sure that our data is coming from a population, or is it sample data? Is it a subset of a larger population? But for mean, we still need to keep track of that. But it's not quite as important from a calculation standpoint. Just very quickly, let's talk about the different components. I've already mentioned them, but let's look at the mean of a population, this formula. Mu, that's the symbol for a population mean. Then we have sigma right here. That is the summation operator. I'll talk more about that on the next slide. That's a very important mathematical operation and a lot of different statistical methods. Go ahead and work on this formula. I'm going to skip that for now, skip the x. Well, no, I do need to talk about the x. Now, the x is an individual score. Now, summation x, that's telling us to sum, add up all the individual scores in our data. Large N, these are the number of elements, things, people, businesses that are in our population that that we've collected data from. And down here we have bar X. That is the symbol representing sample mean. Sometimes I'll say bar X, sometimes I'll say X bar. You might run into some people who are real nitpicky about that. Myself, I'm not. I know what the symbol means when I see it, and that's the most important thing. X bar, bar X, you might, it shouldn't be a problem if you call it one or the other. Again, it represents a sample mean. Then we have the summation operator again. Then we have X again for individual scores in the sample in this case. And then small n, that represents the number of elements in our sample. And elements could be things, could be people, could be businesses, depending on what we're focusing on in our research. Summation operator. I've already mentioned this, but let me just get it clear, get it clarified. Sigma, when you see this, means add up all the values, means add up all of something. When you see summation X, that means add x1, x2, x3, all the way out to xi. And xi represents the last value in the distribution. And we're using x here, but if we were calculating Pearson's correlation coefficient, we would have summation y also. X is just a variable label. Depending on what methods we're using, it could be summation z, summation whatever. But normally when we're dealing with the simpler numerical measures, when there aren't multiple variables involved, it's summation x. Again, summation x, add all the x's, x1, all the way out to xi, however many x's there are. If you have a million x's, a million scores in your data, you'll add all million scores together to come up with your summation x. But don't worry, I'm not going to give you a million scores in a data set. For our practice problems, I'm going to keep the size of our calculations small, since we are going to be doing some hand calculations as well as using Excel. Well, let's go ahead and look at an example. In this example, we have ATM usage data. Each piece of data represents 1 day of ATM usage. Day 1, the ATM at Reesers and Tahlequah was used 83 times. Day 2, 64 times. All the way out to day 30, it was used 60 times. Now for the mean, there's no need to sort the data before calculating the mean. Some of the other measures that we talked about, like the median, we need to sort the data before we find the median. It also helps to sort the data before we identify the mode, but for the mean it doesn't matter. It can be in any order. There's no need to sort. But these are the data we're working with, and we're going to consider this a population for our purposes here. This is a population. This is all 30 days during this period. We could just look at maybe 8 or 10 values from this period. We get to take a sampling from this period, which I'll do in the second example. But for this first example, we're going to consider this a population. And to calculate the mean for this population, start with your formula. Mu equals summation x divided by n. And I'm not going to add everything up in the calculator because of time constraints, but you add up all your scores, all of your values. When you do that, you will come up with 2,116. You also have 30 values, so that is going to be your n value. That's the value that you're going to place in the denominator of the formula. Then once you get to this point, it's a simple division, and you end up with 70.53, and I'm rounding to 2 decimal places. And I will go ahead and do this final calculation for you. 2116 divided by 30, 70.5333, and we're going to round to 2 decimal places. In our class, 2 decimal places is going to be the normal rounding method or protocol that we follow. There may be some exceptions down the road, but for now, 2 decimal places. All right, let's look at another example. For this example, we're going to take a sample from those 30 days and calculate the mean for those samples. The numbers I have highlighted in red represent a random sample of 8 scores from the population of 30. 2, 4, 6, 8, 8 scores from that from that population of 30. When I say random sample, they truly were randomly selected. I used a random number generator to identify which values to select from the population. And when I did that, this is what we came up with. And calculating the mean for the samples, just like the mean for the population. Now our symbols are different. Again, X bar, that's the symbol for the mean of a sample. And a little n instead of big N. The little n represents the number of elements in the sample. When we add up all of these x's, 83, 63, 75, 59, 59, 77, 60, and 84, that comes out to 560. We plug in 8 for our sample size. Let's go ahead and do the last bit of math here. And it comes out, believe it or not, right at 70. Our sample was almost identical to the value for the population, and you're not going to see that every time. If you take 10 or 15 different samples from this population of 30, 70 is going to come up, or around 70 is going to come up occasionally, but you also might get a sample value, a sample mean of 62, or you might get a sample value, sample mean of 73. It just luck of the draw here that we ended up with a sample mean that was almost identical to our population mean. Yeah, I want to give you one more example of calculating the mean, and this time I'm going to do it by hand on your exam, and for some of your homework assignments I want to ask you to work it out by hand, step by step, not just the mean but maybe some other calculations as well. Again, by hand, step by step. And this is kind of what I want to see in your work that you turn in, and what I would like to see on the exam when you show your work. The reason I like to see it step by step is because if you have a mistake, I can see more easily where you made the mistake. Of course, simple calculations like this, we just plug everything in the calculator, we don't have to write anything down. But once we get into some more involved calculations, it's good to do it step by step. And this is kind of what I'll be looking for when I ask you to do the calculations by hand. So start with the formula, and we're going to calculate a sample mean. The symbol for a sample mean is X bar equals, and pardon my drawing, my writing, and I don't get along well with this tablet, so it may not always look that great, but bar X, or X bar, equals summation X over a little n. Okay, so the first thing we need to do, and I will use my calculator on this, and we'll go through the process because we got the numbers and we got to get the numbers. We have 83 plus 63 plus 84 plus 75 plus 59 plus 59 plus 77 plus 60. We should have all 8 of our values plugged into the calculator. We have all 8 of our values in there. Let's go ahead and hit enter. 560. So we have bar X equals 560, and our sample size is 8. Now we just divide that 560 by 8. And I could have just entered divide by 8. I added an extra step there in the calculator that I really didn't need. And our sample mean is 70.00. Go ahead and put the 2 decimal places in there, since we're shooting for 2 decimal places with all of our calculations. And usually your mean is not going to come out a perfectly whole number like this. Yeah, very simple example, but when I ask you to hand solve or hand write your calculations, start with the formula, then go step by step, plugging in your values, doing any intermediate calculations that are needed, and work your way all to the very end. Most of the time, most of the calculations we're going to do in here, it's not going to take more than about 6 or 7 steps. Even the most complicated ones, even when we get to Pearson's R and we hand calculate that, 6 or 7 steps should get you to where you need to go. One more thing about calculating the mean. Excel, there's a function in Excel, makes it real easy. And I want to do a separate video on some of the different statistical functions available to us through Excel, and show you how to get those plugged in and how we can set up a report sheet for our different statistics. All right, that's it for this video, and I will see you in the next one.